So today let's talk about an interesting topic and very important topic, which is waves, under vibrations and waves. So the first question that we should ask ourselves is, what is a wave? So a wave is just a disturbance that transfers energy from one point to another without the transfer of matter. For example, when waves moves on water, the water particles do not travel with the wave. They only move up and down, but the energy moves forward. And we have two types of energy. The first one is mechanical energy. Mechanical energy is a type of energy that requires a medium. For example, sound waves requires air, water waves requires water, and string waves requires a string. So those are the types of mechanical waves. So this one, they require medium for them to occur. For example, string waves, for them to occur, they need a string. The second one is electromagnetic waves. So electromagnetic waves, they don't require or they don't need a medium. For example, light waves, radio waves, and X-rays. So these are the types of electromagnetic waves. Now we are going to talk about another important thing, which are the classes of waves. Or waves, they can either be transverse or longitudinal waves. So transverse versus longitudinal waves. So when we are talking about transverse waves, here particles vibrate perpendicular to the direction of wave motion. So as I said, transverse waves vibrate perpendicular to the direction of wave motion. So the example we can give is wave on a string. So for longitudinal waves, a particle will vibrate parallel to the direction of wave motion, e.g. Sound waves. So the key point to know there is, if vibration is perpendicular, then it's transverse. If vibration is parallel, then it's longitudinal waves. Understand waves. Let me try to draw a diagram of a wave. To understand the parts of this wave, this highest point here, we call it crest. The highest point of a wave, we call it crest. So crest. Then the lowest part here is trough. Then I'm sure you have heard of wavelength. When we are talking about wavelength, wavelength is the distance between 2 points in phase. For example, we have this crest here. The distance from crest here to crest is wavelength. This distance from here to here is wavelength. For example, or trough to trough is wavelength. When we just look at this is just the length of a complete wave. For example, from here to here, it's a complete wave. So when you are talking about wavelength, this is just a distance between 2 points in phase. So this is wavelength and this is wavelength. Also, this is wavelength, and the distance from here to here, it's also wavelength. Another thing which you should know also is the amplitude, which is just the maximum distance from equilibrium application. So amplitude can either be the distance from here to there. This distance is amplitude, or from here to here, it's amplitude. So that's just what we mean. So another thing that you should know is frequency. Frequency is just the number of oscillations per second. So the last thing is period, which is the time taken for one complete oscillation. So you know this formula that the frequency is equal to 1 over period. That's the formula of frequency. Now let's talk about the speed of a wave. So speed of a wave can be found by one of the formulas we can use to find speed of a wave is speed is equal to frequency times wavelength. So when you multiply frequency times wavelength, you come up with what? Velocity. So this formula is one of the most important formulas in what? In waves. So sometimes they may not require you to go direct to the point. You may need to do some applications for you to use this formula. Do an example. So given that you have a wave has a period of 0.125 seconds. So if you have been given like that, we know that the formula of speed is equal to frequency times wavelength. Now if you look in the formula, we haven't been given what? The frequency, but we know that frequency is equal to 1 over period, which means when we do 1 divided by the period, we are going to get 80 hertz. So now when finding speed, we are just going to say 80 times the wavelength, which is 0.5, and the answer is going to be 4 meter per second. So when you have been given the frequency or period and the wavelength, the formula you use to find the speed is frequency times wavelength. Also, another formula you can use when you have been given the period, you can just say speed is equal to wavelength over period instead of finding frequency first. So another important is when finding speed on for waves on a string. So when finding waves on a string, we use the formula which is speed is equal to the square root of tension over the linear density. So linear density is just the mass per unit length of the string. So let me write it. Speed is equal to the square root of tension over linear density, where linear density is equal to mass over length of the what? Of the string. Let's try to do an example. So this example goes like this. A string of length 2 meters and mass 0.04 kg has a 5 kg mass suspended from one end. Find the speed of transverse waves. That we should find is the tension. We just know that this string has a length of 2 meters and mass of 0.04 kg. So we know from Newton's second law of motion that tension can be found, in this case it will be just equal to mass times the acceleration, which is, what's the mass? The mass is 0.04. The mistake that students make is they will do the vice versa. They might get the mass of the object which has been suspended, but here we are finding the tension of the what? Of the spring. In fact, I'm the one making the mistake. The value we should use is the mass of the object, not the mass of the what? Of the spring. This is the mistake that most students make. We use the mass of the string to find the linear density. So here, to find the tension, we use the mass of the what? Of the object. So in fact, I'm the one who was making a mistake here. So we use the mass of the what? Of the object which has been suspended. So in this case, we get 5 times, what's the acceleration? 9.8 81. So at the end, the answer we are going to get is going to be 49. So this is our tension. So we go again to find the what? The linear density. So how do we find linear density? Linear density is equal to mass of the string over the length. So in this case it's 0.02 over what? Or 0.4 over 2. So let me create space for solving this. And that the linear density is going to be 0.02, which is kg per meter. Now to find the speed, we just go in the formula, which is 49 for the tension over 0.02 for the what? For the linear density. At the end, the answer for speed is going to be 49.5, which is meter per second. So that would be our answer. So there is a second here, it's just that it's failing to write it here. So there is a meter per second there. So that's our speed. So just know that when you are dealing with the string, use the formula tension over the linear density in the square root. So there is most of the calculations you are going to find on waves, it's going to be more on the same thing, speed. So it can either be speed on a string or that other string for a normal maybe transverse wave. Yeah. So just know those formulas and practice a lot. Let's talk about interference of waves. So interference happens when two waves meet. So when two waves meet, there are two possible things that can happen there. The first one is constructive interference. Here waves meet in phase, whereby when they combine, their amplitude is going to be the addition of the two waves, the two waves amplitudes. So in constructive interference, waves meet in phase. At the end results in larger amplitude. Destructive interference. Here waves meet out of phase, meaning there is going to be reduced or zero amplitude. Just as I said, destructive waves will meet out of phase, which means there's going to be reduced or zero amplitude. So what you should know is, even when they ask you to calculate maybe the summation of amplitude of waves, so in constructive, if they are in phase, you are going to add the amplitudes, but if they are out of phase, you are going to subtract the other phase from the other amplitude from another amplitude of another wave. So this is the end of the lesson. See you in the next video as we look to more on vibrations and